Hello class, let's learn about solutions, precipitation reactions, acid and bases, and gas forming reactions. Let's look at few definitions. Solution is a homogeneous mixture of solute and solvent. Solute is the substance being dissolved. Solvent is the substance that's dissolving the solute. Aqueous solution is when a substance is dissolved in water. So as an example, let's say that you are going to dissolve some salt in water. Salt is your solute and water is your solvent. So you are making a solution of sodium chloride. We called it a aqueous solution because the solvent is water. The covalent compounds dissolves into individual molecules. So we have glucose here. When you dissolve in water, we get individual molecules. However, the ionic compounds dissociates into ions. Example, sodium chloride. And when you dissolve sodium chloride in water, it makes a aqueous solution of sodium chloride and it dissociates into sodium plus ions and chloride minus ions. Here's another example, magnesium chloride. You will get magnesium 2 plus ion and 2 chloride ions. When you do a chemical reaction or when you write a chemical reaction, it is important to know whether the components are water soluble or not. These are the solubility trends we are going to use to predict whether these components are soluble in water or not. First, let's take sodium chloride. So, number one rule says salts of alkali metal ions are soluble. So, sodium chloride is soluble. Silver nitrate. Rule number one does not apply to silver nitrate. However, rule number 2 says nitrates are soluble. So, silver nitrate is soluble. Silver chloride 1 and 2 does not apply. However, in rule number 3, it says silver compounds are insoluble. Magnesium nitrate. Rule 1 does not apply. Rule 2 says nitrates are soluble. Lead acetate. Rule number 1 does not apply and 2 says acetates are soluble. Calcium sulfide. So first 5 rules does not apply. However, in 6 it says compounds with the -2 anion are insoluble. So calcium sulfide is insoluble. Magnesium chloride. Rule number 4 says chlorides are soluble. Barium nitrate. Number 2 says nitrates are soluble. Barium sulfate. Number 5 says sulfates are soluble. However, except for calcium and barium. That means barium sulfate is insoluble. Magnesium sulfate is soluble according to rule number 5. Sodium sulfate is soluble according to rule number 1. Lead iodide is insoluble according to rule number 3. Iron chloride is soluble according to rule number 4. Also, you have to remember that these have a priority rule. So you go to the first rule, and if that doesn't apply, you go to second rule and so on. Let's see how to use that knowledge in writing chemical equations. First, let's look at precipitation reactions. Precipitation reactions are the reactions that produce a solid. When you react two ionic compounds, they undergo double displacement reaction. So let's look at this example. Sodium chloride and silver nitrate reacts to produce sodium nitrate and silver chloride. As you can see, they simply swap their ions, sodium nitrate and silver chloride. So we are going to use the solubility trends to predict the phase of each of these components. Sodium chloride, according to rule number 1, is soluble. That means it's aqueous. Silver nitrate, according to rule number 2, is soluble. So this is aqueous as well. Sodium nitrate, according to rule number 1, is aqueous. Silver chloride, according to rule number 3, is insoluble. That means it is a solid. So this is our precipitate. Let's practice more. Write equations with phases. First one, lithium bromide and lead nitrate. So we are going to write the equation first and then we are going to balance the equation. You need to see that we did a double displacement, lithium nitrate and lead bromide. So we are going to decide the phases of each of the components next. Lithium bromide is soluble according to the number 1 rule and it's aqueous. Lead nitrate soluble according to number 2 rule and it's aqueous. Lithium nitrate soluble according to number 1 rule, aqueous, and lead bromide is insoluble according to number 3 rule, so it's solid. So you apply the same pattern and identify the rules and identify whether each one of these components solids or aqueous. So iron sulfate is aqueous, sodium hydroxide is aqueous, ferrous hydroxide is solid. So in rule number 7 says hydroxides are insoluble. Sodium sulfate is aqueous. So you can check all these components one by one. Let's use all that knowledge in writing net ionic equations. Let's take this example. Sodium chloride plus silver nitrate produce sodium nitrate plus silver chloride. So you are going to balance the equation first and then you are going to assign the phases. To assign phases, you are going to use the solubility trends. So now we know when you dissolve an ionic compound, it exists as its ions. As example, sodium chloride exists as sodium plus aqueous ions and chloride aqueous ions. Same goes to silver nitrate, silver plus ions, aqueous, nitrate ions, aqueous. Sodium nitrate, sodium plus ions, aqueous, nitrate, aqueous. Now silver chloride is a solid, so we don't break solids, liquids or gases into their ions. We write silver chloride as it is. Next step is to take out the spectator ions. Spectator ions are the ions that exist in both sides. So we take off sodium and nitrate. Now we are going to write the net ionic equation. So we have chlorides and silver in this right, and we are going to have silver chloride in product side. This is the actual reaction that is happening in this reaction. Let's do another example. So it says barium perchlorate and lithium phosphate. First we are going to write the chemical compound. Barium 2 plus, chlorates makes minus. And if you do the crossover method, we are going to end up with the compound formula as this. Next, lithium phosphate. Lithium makes +1 ions. Phosphate is a 3- polyatomic ion. So we do the crossover method. This is your compound formula, Li3PO4. So let's write the equation and balance the equation. And then you are going to assign the phases. So, and now we are going to write your ions. You have 3 barium 2+ ions and 6 chlorate ions in aqueous phase. In this case, you have 6 lithium plus ions and 2 phosphate ions in aqueous phase. So this is a solid. So we don't break the solids into ions. We write it down as it is. Now in this case, you have 6 lithium ions and 6 chlorate ions in aqueous phase. Next, we take out the spectator ions, chlorate, 6 chlorate and 6 chlorate, 6 lithiums and 6 lithiums. And this is your net ionic equation. Let's look at acids and bases. Acids are the substances that dissolve in water and produce H+ ions. Example, hydrochloric gas dissolves in water, produce H+ ions. Nitric acid dissolves in water and produce H+ ions. Bases are the substances that dissolve in water, produce hydroxide ions. Ammonia is a base because it dissolves in water and produces hydroxide ion. When you add acid and base together, they make a salt and water. Example, magnesium hydroxide and hydrochloric acid produce a salt, a magnesium chloride, and water. Any reaction that produces a gas can be called as a gas forming reaction. So aqueous carbonic acid is unstable. So in the aqueous media, it dissociates into water and carbon dioxide. As example, when you react hydrochloric acid with sodium bicarbonate, it produces its salt, which is sodium chloride, and carbonic acid. However, carbonic acid is unstable. It breaks down to water and carbon dioxide. Same goes with the sulfurous acid. So when you have sulfurous acid, it breaks down to or decomposes to water and sulfur dioxide. As an example, when you mix nitric acid and calcium sulfide, it makes sulfurous acid. However, it is unstable and it decomposes to water and sulfur dioxide. When you mix hydrochloric acid with sodium sulfide, it produces hydrogen sulfide, which is another gas forming reaction. If you mix metal with the acid, it makes salt and hydrogen gas. As an example, let's say you mix zinc with hydrochloric acid and it makes hydrogen gas. This is the end of this session, and please let me know if you have any more questions. Thank you.